Okay, today we're going to work on simplifying radicals. Okay, a radical is just like this little square root sign, or it could be a cube root. Remember, if you don't see anything right out here, it's understood to be a 2 right there. Okay, it's understood to be a 2. That means it's the square root. And remember right here, if you don't see anything, that's understood to be a 1. The exponent of the 25 is understood to be a 1. All right, technically you can rewrite this as 25 to the 1/2 power. All right, let's see where we get that. The 1 comes from there, from the exponent inside, and the 2 is in the denominator, and it comes from the root, kind of like a root cellar, or roots are in the ground, and the basement, the denominator, the dungeon is in the ground, that kind of thing. It's kind of cutesy-tootsy ways to remember it. All right, so we understand that part right there. We've kind of done that before. But let's go back to what we're doing right here. Basically, we're trying to find out the square root of 25. That means how many pairs, since this is understood to be a 2, how many perfect pairs can we get out of this right here? Well, we all know it's 5. We all know that the square root of 25 is 5. We get that. But let's see why. Basically, we can take the 25 and we can break it down into the factor tree. What times what gives me 25? 5 times 5. Remember, we can't put a 1 in these because these are prime factors and 1 is not prime. Okay, doke? So that means right here, technically, this is 5 times 5. Right? All right, remember there's an understood 2 right here, so that means it wants a pair. It wants two numbers that are exactly the same. Oh, well, look, there they go. So there's 2 5s. So I'm just going to bring one of them out. So the square root of 25 is 5. Ta-da! All right, so let's make this a little interesting. So what if we say the square root of 50? All right, a couple of different ways you can do that. First of all, if you see that and you recognize right off the bat that there's a perfect square in there, so it's really the square root of 25 times 2. You see that? All right, so you can break that up into 2 of them times the square root of 2. Well, we know that the square root of 25 is 5, and then whatever's left over would just be 2. Okay, doke? All right, another way we can do that is also through prime factorization. So we got 50 right here. We're going to say, okay, I know that's 5 times 10. 5's prime, so we're good. 10's not prime, so that's going to be 5 times 2. All right? So we're going to come back here and rewrite this as, I'm going to start with the 2. 2 times, and then 5 times 5. Since there's an understood 2 right here, it wants a pair. Oh, well, look, there's a pair. Ta-da! Right there. So that means I'm going to bust one of these out, and it's going to be 5. And the poor 2 is left there all by him's lonesome. Okay? Now, that's kind of one of the easy ones. So let's see how we can take this concept and apply it to something that's a little bit more complicated. So, because if I'm looking at this right here, if I'm looking at this one, the square root of 216, and it says simplify. Sorry. Now, of course, you can do that in the calculator and find out what it is exactly, but we don't necessarily always want the decimals because you're probably going to have to round them. So if it wants it simplified, it wants you just to break it up and find perfect squares in there. Goodness. Sorry, people. All right, so I'm going to come over here to the side, and let's do 216. So you're going to sit there and look at that, and it's like, oh, I don't remember. Well, look, that's an even number on the end. So you know it's divisible by 2. If you don't know how to do that, just go in the calculator and say 216 divided by 2. I'm going to do it like this. 2 divided by 2 is 1. That's a 0, 16, and 8. Okay, no, yay me. We're not done because that can keep going. This 108 is not prime. I know that that 8 is a even number, so I know it's divisible by 2. Keep a going. I know that 4 is a even number, so it's divisible by 2. So that's 27. Okay, not done. 27's not prime. I know that that can be divided into 3 times 9 is 27. Yay me. Then right here, I'm going to say that that is 3 times 3. Good-o? All right, so there's 1, 2, 3 2s and 1, 2, 3 3s. So I'm going to rewrite this as 1, 2, 3 2s, 1, 2, 3 3s. All right, remember there's a squared out here. It's understood to be squared, so I'm looking for pairs. There's a pair, so he's going to come out. And then there's a pair, so he's going to come out. Now we got to multiply these guys. And inside we're left with a 2 and a 3. Okay, so now we're going to do our multiplication. 2 times 3 is 6. And then also it works out that 2 times 3 is also 6 inside there. So 16 is coming out to be 6 times the square root of 6. Okay, quickness, what if they said the cube root? See, the cube root of 216. All right, well then I'd be coming through here and I'd be looking for triplets. I'm not going to have triplets. Okay, so here we go. Write faster so that we can hurry up this video. Oops, sorry. All right, so this means find sets of 3. All right, then. There it is. So he's coming out. And then this is a set. So he's also coming out. All right, nobody's left inside there. So it just would be 2 times 3. So this is going to equal 6. Now you can check it by saying 6 times 6 times 6 and see what you get. See if that works. It should. All right. So that's how we're simplifying radicals. Easy breezy, lemon squeezy. All righty. Have fun.